Good afternoon. This is Ward Harriman, AE6TY. It's been some time since I did a video concerning SimSmith or SimNEC, and it's not that I haven't been working on it, it's just I haven't done any videos. So I figured I'd take this chance to show you a little bit about what's been going on and what is available in the standard web page download for SimNEC. The first area that I was working on over the last few months is the auto segmentation of wires in SimNEC. And here you can see a typical wire. It's got a little thing hanging off here. And I've put the source for the wire or the drive for the wire in the middle. And I have, you can see here, I've assigned it using a variable called LOC. Now in traditional NEC 2, you would do the segmentation of the wire and you would assign the source as some percentage along the wire, for example in EasyNEC. And EasyNEC would pick the segment, the center of the segment that was closest to where you had specified it. So if you specified it at 10%, it might pick this segment here because this is the closest to 10%, or maybe here. And if you were to scan or sweep the location along here, what would happen is it would be here for a while, and then it would jump to here, and then it would jump to here, and then it would jump to here. And the result of that would be a sawtooth in the impedance as seen looking into the antenna. Well, that sawtooth can be pretty disturbing, and I got several emails concerning that because when you move the location around and get that sawtooth, you naturally believe that something is wrong. More importantly, in almost all other NEC implementations or NEC front ends, if you were trying to play with an off-center fed feed point and you were playing with the feed point moving around here, there would be no effect in moving the feed point, and you would notice that, and you would have to go specify a wire, and you would have to have a thing hanging off here and a wire and a thing hanging off here. And that's a pretty painful process if all you're doing is trying something simple like moving the drive point around. SimNEC does automatic segmentation, and one of the things I wanted to make sure worked was if you put your drive point right there, that's where SimNEC would put the drive point exactly where you want it. And if you were to put a trap over here or someplace else, SimNEC will endeavor to place those traps on the wire at precisely the location you specify. In order to do that, it has to do some relatively simple things. And let's see what it does. So let's go over here to loc, and I'm just going to use the down arrow and move it over right here. Now you'll see that just moving it ever so slightly off center changes the segmentation, because now the result is not in the middle of a segment under normal circumstances. So I'm going to decrement it, and you can see now that this segmentation over here and this segmentation over here has changed. And if you come up here and hover, you'll see that's what has happened is SimNEC has taken that wire and divided it into three pieces. It's got a center piece with an odd number of segments and a drive in the middle of the middle segment. And it's got a couple of extra wires hanging over here on the side to fill out the original wire. And if you look up here at the top, you'll see that the wires are named based on the original wire name. Now, one of the things it tries to do is to make sure that whenever you have two wires connected together on a point, the segment length of this wire and the segment length of this wire are no different than a factor of 2. So let's watch what happens over here as I move the location over. Again, I'm going to use the down arrow and move it over. And you can see that it's still got this one in the middle, and it's got one on the left, and it's got one on the right, and it's adjusting the number of segments on those wires so that the segment length to length ratio is no more than 2. Let's continue. We're still walking over. Here we have a wire there, just like before. This wire is growing, this wire is shrinking, this wire is moving over. And now we see something interesting happened. This wire is now being segmented. And the reason it's being segmented is that its original length, now its length is less than twice that segment length. But if I reduce this, now this segment length is shorter, and this needs to be segmented so that the ratio is no more than 2. Now, notice that it stopped segmenting it here, and it did that because now there's one wire along here. This wire on the end got thrown away, it wasn't needed anymore. And now I only have 2 wires, and this segment is now long, and so that one is not too long, and we can keep going. Now, there'll come a point in time where we need to segment again. We're getting there. Patience. There. So what happened? Now this wire is little teeny wire. This long one has segments, each of which is no longer than that one times 2. This one now is longer than that one times 2, so it got segmented. And we can keep going. Oh, see, now what happened is this segment is really short. This wire was more than twice as long, so it cut it in half. And now even that half is too long, so it cut that in half. And let's zoom in on this, and we'll watch what happens as you get closer and closer to the end of this wire. You'll see segments on the end here get taken off, cut in half, in order to make this segment no more than twice as big as that one. So there you go. So you can see that SimNEC is placing that drive at exactly the right place and segmenting around the drive instead of placing the drive around the segmentation. Reviewing the video, it occurs to me that I did not show the actual sweep of the location and show that there was no sawtooth. So I came up here and I added the loc as a sweepable variable. I'm going to sweep it from 1 to 99% and turn it on. Here's the trace, no sawtooth, which is the goal. Notice that it's not symmetric, and it's not symmetric because I have this little wire hanging off the end. So I'll jab this back into the video and move on. Sorry for the interruption. Now, one more interesting thing, let's just go up. We'll put in let's put in a trap. I won't put a value. I won't put a reactive component in here. I'll just make it a short circuit. You can see there's a wire here, and I'm going to add that in. I can hit reset view. That gives me that. Let's get rid of the field. Now, this align button here walks around to the axes. So right now we're looking down the y-axis. And you can see here that, again, here's my trap, and it's been placed at exactly the right location, and it has been, the wires have been segmented around the placement of that. And in this case, you'll see some other little wires. I could have put these two together, but it didn't. So the point is, now where you place your traps and where you place your drives are fixed in space, and SimNEC will segment around them. Okay, what else happened? Well, the other thing that happened is SimNEC changed to being feet and inches for lengths and diameters. And that was to make all you Americans happy, including me, and to make it compatible with how EasyNEC has been used for decades. So it was just easier to go to feet and inches, and to specify, in fact, the wire diameter now instead of radius. And I'm going to say I want to make this out of 10 gauge wire, so in SimNEC I can say 10 gauge, and point at a wire here, and you'll see up here in the top of the wire report, you'll see that it says 0.102, and that's in inches, and that's what a 10 gauge wire is. There's some other parameters you can throw in here. You can control the default number of segments per wavelength. You can change the units from, I have meters right now, I really should have said feet. Actually, I'm going to default it. So let's get rid of feet. And now the length needs to be like 33 feet. And there we are. Again, the diameter. Now everything's specified in feet up here. Right? So that's the major changes to SimNEC. You can go read the portal document in Documents to see what other variables can be set. Basically everything that was design specific. So units and segments per wavelength and mhos per meter, all those things are now specified here instead of the portal. Down here you can see that we had reset view. I showed you a line where you can walk around looking down different axes. You can make it auto fit this, which mostly works. It occasionally gets kind of buggy. And you can tell it that you don't really care about segments, you really care about wires. So if I come down here and click on this, now it's just showing me each individual wire that it's generated instead of the segments. So I can show segments or I can show wires. So that pretty much wraps up the modifications to SimNEC. And now I'm going to move on to other things that are in 1.5 that you may find useful. New redesign. No, I don't want to save that. All right. So one of the common things that people regularly run into is the desire to have more control over the updating and the values for a given parameter. So the first thing that got added was the ability to specify the range, the legal range of this particular parameter. I right-clicked on it, and now I get from and to. And if from and to are both 0, then there's no range. But I can set this to be no less than 1 and no more than 1K, for example. Now if I come over here and I use the wheel, you can see it goes up, doesn't go above 1K. I go down, doesn't go below 1. Another thing that got put in here, again, right-click, is before I had the linear increment, so you could go up and down by 1 by the increment. And a new feature got put in called discrete. And discrete says it's only going to take on these values for each decade. So it doesn't have any effect when we first put it on. And if I type in a number, it doesn't force that number. But if I use the up and down arrows, you'll see it goes through the values. So 1, 1.4, 2, 3, 5, 7, 1. Remember, 1, 1.4, 2, 3, 5, 7. So this is useful if you want to be able to change this a little faster and not use higher gains on the gain wheel. So next feature. The other feature that got added was the ability to write an equation for this parameter. And again, this can be a little fickle. If you're using it and you run into problems, please let me know, but you should be warned that it can be a little fickle. So right here, I'm going to click on this and I'm going to say, I'm going to give you an example. Let's say I want to specify the impedance using the magnitude and angle rather than R and X. So the way I would do that is I'm going to talk about the gamma first, magnitude and angle. So here it says, given the magnitude rotated by angle, that gives me a gamma. The arc gamma delivers an impedance, and the impedance will be put here in ohms. So I'm going to say yes. And now I can change this and you'll see this moves around. And now this is kind of nice because I can do this. I'm going to get rid of this, control click on this. I'm going to do an angle from 0 to 360, and I'm going to do not too many points. And I'm going to do a magnitude from 0 to 1. And just for fun, let's do a Smith of dots on Zn in the plotting, so I can turn this off. And here are the points that are being generated by sweeping the magnitude and the angle. Okay, another thing I added, let's go new, is, I don't want to save that, is there's lots of times when people would like to be able to draw the differential balanced circuit. Now, SimNEC always does differential analysis. There is no common mode analysis, but it gets drawn as though it's not balanced, and I understand wanting to do that. So I put in some more library elements you can add down here. So if I go up here to libraries, I can pick some. I'm going to pick the differential library. I'm going to click on this. And you'll see now I have a bunch of new elements down here. And suppose I wanted to match that. That would be an inductance and a capacitance. And so it doesn't draw a nice arc, but it lets you draw it this way up here. And I can go over here. Oh, it doesn't want to let me drag to. Bug. I will fix that bug. So this lets you, the point is, this lets you play with drawing it as a differential thing. There's a couple of other things down here. There's this guy, which is a 4-to-1 Guanala balun. And I can flip this horizontally to flip it back and forth. There's a couple of others. Here's a Rothruff 4-to-1 balun. And again, I can flip that horizontally. A choke balun. Flipping it horizontally probably doesn't make any difference, but you could. So series capacitor. Anyway, the point is these are down here. You can turn this off by going up here and clicking it off. Okay, what else have I done? Compound assign. Okay, so another thing that if you're writing programs, this tends to be, okay. So SimNEC has, or Anvil has an assignment operator that called the dot equal. And dot equal allows you to say things like the L parameter should be, ohms should be 25 and J ohms should be 12. Now that doesn't look like a particularly useful thing. You could have just set it, and that's true. Another thing that you can do now is you can say L dot ohms. Notice that I used a curly bracket here, and L dot J ohms dot equals 12 and 23. Okay, now again, this is not particularly rocket science, but one of the nice things about this is that you can now define a function which returns multiple values. I'm going to just return A and B. And now I can say and get this function to return multiple values which are assigned to multiple variables. This is not a function that's in Java, so it took me a while to realize how bloody handy this is if you happen to be writing programs that return more things than just a number. Okay, what else did we add? I've been playing with a routine which will find impedances, matching impedances, and this is under development, but I can give you a preview. Let's do okay, so this returned a whole bunch of potential solutions, and each one of these solutions is useful in a given topology. So for example, it's reactances, so I'm just going to use impedances, and it's got a list of things. The first thing on the list is a shunt reactance and a series reactance to match Zn to Z0. So if I were to say R1.ohms R2.ohms, nope, because they're reactances. Not having much luck here. Notice no solution, so I'm going to have to go to 1. And 1 is series shunt. So I'm going to rotate this. Got to get rid of the resistances. There we go. Long, complicated. Sorry to drag you through that. But it gives you an idea of the kinds of things you can do here. There's a utility in here. This is shunt series, an alternative shunt and series. So for example, this is one I can do. This is, I'm sorry, shunt series. So like if I used 3 instead of 1, it gives me the other way to it. The next one is a low pass T, and I'm actually working on this. This basically says you want 0, or you want an infinite capacitance here. This is pi, and this is T. So this is basically the reactances you want for your T. I'm not going to go into that at this point. That's under development. There's a paper pointed out to me by Dan McGuire, which references a paper by a gentleman by the name of Sabin, who does a great paper on T matching, and I'm in the process of integrating that to be a little more sane than 0 for the reactance, because you can't get 0 in a reactance. So that's kind of the big thing going on in that. And that pretty much tells you what's going on and a little preview about what I've been working on. Long-winded, informal. Hope it was useful listening. Talk to you later. This is Ward Harriman, AE6TY. Thanks for watching, and thanks for using SimNEC.